We are gonna consider ideas of these two problems. This problem is from AMC 10B 2020. And if you want to learn other important ideas, as I said before, feel free to send message to my WhatsApp number in the description. For these types of problems, one way is to create quadratic equation and find a in terms of b, then replace. Another way that is better is that you should divide both sides by b squared. So let me write main equation a squared plus b squared equals 5ab. Then we should divide both sides by b squared. So it will be a over b squared plus 1 equals 5 times b will be cancelled, a over b. Okay, now we can take it to left hand side. A over b squared minus 5ab plus 1 equals 0. Now we can use changing variable. So let's consider. So the idea here, when you divide, we can call it idea 1. Idea 2, changing variable. So we can say a over b, for example, equals w. So it is w squared minus 5w plus 1, 0. Then we should apply quadratic formula. It is what? If we have ax squared plus bx plus c equals 0, then x equals negative b plus minus square root of b squared minus 4ac all over 2a. Okay? So w equals negative 5 plus minus square root of 5 squared 25 minus 4ac 4 times over 2. So it will be 5 plus minus square root of 21 over 2. So w is what? Is a over b. So we found a over b is this. Okay, now let's try next problem. This problem from AMC 10. Okay, how many positive integers n satisfy n plus 1000 over 70 equals floor of square root of n? This part, floor, is the greatest integer not exceeding x. For example, floor, you should round down. Floor of 2.4 is 2. Floor of 2.9 is 2. Floor of 2 is 2. And for negative numbers, because y 2.4, 2.9 are between 2 and 3, so you should round down. For example, floor of negative 2.4 is what? Negative 3. Why? Because this one is between negative 3 and negative 2. Negative 2.4 is here. When you round down, it will be negative 3. For example, floor of negative 2 is negative 2. Okay, now one important idea, so much important in these types of problem, is that it will be idea 3. You should consider n equals, when you have floor something like this one, because we have floor of root n, you write root n as k plus r. K is integer part and r is fractional part. And we have one condition. R should be greater than equal 0, less than 1. Okay, now we want to use this here. N plus 1000 equals 70. So let me write n plus 1000 equals 70 times floor of root n. Okay, so we can say this one, because it is integer part of root n, so we can say it is equal to k, this part 70k. Because root n is this, so n is this part squared, so k plus r whole squared plus 1000 equals 70k. So if we expand, k squared plus r squared plus 2kr plus 1000 equals 70k. And then we can take all things. Because we have this condition, it is a quadratic equation in terms of r. So we can write r plus 2kr plus k squared minus 70k plus 1000 equal to 0. Now, we want to find r is what? Okay, again, we should apply quadratic equation that I explained here. We should use this formula. We can take a screenshot from idea 2, quadratic formula, and here, if we apply that, r equals negative b, negative 2k plus minus square root of 2k squared, b squared minus 4ac, minus 4 times 1 times k squared minus 70k plus 1000. All over what? All over 2. Okay, let's divide both numerator and denominator by 2. We can cancel 2. Inside square root, we should divide by 4. Here, inside this square, we should divide by 2. Okay, so it will be negative k plus minus square root of k squared. Negative k squared will be cancelled. Negative negative 70k minus 1000. So this is our r, and r was what? R was from 0 to 1. At least 0, strictly less than 1. So we can conclude here R, which is this number. At first, inside square root should be positive, non-negative. 70k minus 1000, which is inside square root of this 0. We can divide both sides by 10. So 7k is greater than equal 100. So we can divide both sides by 7. 100 over 7, which is 14 point something. So we can say because k is integer, k is at least 15. It is the first condition that we've reached. Now this one, because it says r should be greater than equal 0, here we should select plus because negative, negative, it will be negative. So it will be negative k plus root 70k minus 1000. Now we can say negative k plus square root of 70k minus 1000 is greater than equal 0, less than 1. Pause the video and try to solve it first on your own, for which case it will be good. Let's consider this part first. We can add k to this side, and so k to both sides. K less than or equal, or you can take negative k here. I want to consider only this inequality. 70k minus 1000. Let me write it. Now we can, both sides are non-negative numbers. We can raise to the power of 2. So k squared is less than or equal 70k minus 1000. And then it will be k squared minus 70k plus 1000 less than or equal 0. Let me tell you how to find quadratic equations like this. It will be ID of 4. When we have a quadratic equation like this, for example, when we have ax squared plus bx plus c, then if a is positive, it opens up. If a is negative, the figure opens down. Here it opens up, and we want to see for which k it is positive. So if we find these two roots, between them, it will be less than or equal 0. Outside the roots, it will be greater than 0. So here, we should find the roots. And for finding the roots, I can say k minus 20 times k minus 50 less than or equal 0. Okay, minus 20 minus 50 minus 70, product of them plus 1000. So the roots are 20 and 50. And then I can say this part, this one 20, this one 50. So k is greater than equal 20, less than or equal 50. It is the second result that we've reached. First result was k greater than equal 50. And we know when k is greater than equal 20 in second condition, because all conditions should be satisfied. So first condition will be satisfied. So we should focus on this. Now one part is left, this one. We should analyze under what condition this part is correct. So again, for this one, we take negative k to right side, it will be plus k, so root 70k minus 1000 less than k plus 1. Now both sides are non-negative numbers. We can raise both sides to the power of 2. So left hand side is 70k minus 1000. Right hand side is k plus 1 squared. So it will be k squared plus 2k plus 1. Now if we take all things to right hand side, then it will be what? Let me write. 0 k squared 2k. When you take 70k to right hand side, negative 70k. Negative 70 plus 2, negative 68k. Negative 1000 to right hand side, 1000 plus 1, 1001. Okay. Now we want that this function be greater than 0. It means what? If we find the roots, it opens up because of idea 4. Because a1 is positive, so it should be outside roots. So we should find roots. Again, we use quadratic formula, negative b, 68 plus minus 68 squared minus 4ac, 4 times 1001, all over 2. So we can divide both numerator and denominator by 2, and inside square root we should divide by 4, so it will be 34 squared minus 1001. Now 34 squared is 2 times 17, so 4 times 289. 17 squared. 4 times 9, 36. We have 3. 4 times 8, 32 plus 3, 35. 3, 4 times 2, 8 plus 3, 11. So 1156 minus this, which will be 34, plus minus 155. Okay, if you calculate. And we know square root of 155 is 12 point something, because 12 squared is 144, 13 squared is 169. 34 plus this is 46 point something. 34 minus this is 22, 21 point something. So k 21 point something will be this part, or 46 point something here. So because k is in this part, k is less than or equal to 21 because k is integer. When it is greater than 46 point something, k will be greater than or equal to 47. So good case are what? If we apply second condition here, good case are 20, 21, 47, 48, 49, 50. These cases satisfy here and here. So 1, 2, 3, 4, 5, 6. We have 6 cases and the answer. And for each of these cases, R will be good. And we have a good answer. So the answer will be C. Okay, if you, as I said before, if you want to learn more ideas, important ideas in geometry, combinatorics, algebra, number theory, feel free to send message to my WhatsApp number in the description. Thanks. Don't forget to subscribe and like the video. Bye.